Generators are fascinating devices that transform mechanical energy into electrical energy. Understanding how they work reveals one of the most important principles in modern technology, powering everything from our homes to entire cities. A generator is a device that converts mechanical energy into electrical energy. Think of it as the opposite of a motor. While a motor uses electricity to create motion, a generator uses motion to create electricity. This conversion process is the foundation of how we produce most of the electrical power we use every day. Generators work based on electromagnetic induction. This principle states that when a conductor, such as a wire, moves through a magnetic field, an electric current is induced in that conductor. This discovery revolutionized our ability to generate electricity on demand. Faraday's law mathematically describes electromagnetic induction. The formula is epsilon equals negative n times d phi by dt. This tells us that the induced electromotive force, or EMF, is proportional to the rate of change of magnetic flux through the coil. The faster the magnetic field changes, the more voltage is generated. The negative sign indicates the direction of the induced current opposes the change in flux. A generator has three key components. First, the rotor, which is the rotating part containing wire coils. Second, the stator, which provides the stationary magnetic field that the rotor moves through. And third, slip rings, which are conducting rings that transfer the electrical current from the rotating rotor to the external circuit. Here's how a generator produces electricity. First, a mechanical force, such as from steam or falling water, rotates the coil. Second, as the coil rotates, it cuts through the magnetic field lines. Third, this changing magnetic flux induces an electromotive force in the coil according to Faraday's law. Finally, this induced EMF causes electric current to flow through the connected circuit, delivering usable electrical energy. There are two main types of generators. An AC generator produces alternating current using slip rings. The current continuously changes direction as the coil rotates. A DC generator produces direct current using a commutator instead of slip rings. The commutator reverses the connections every half rotation, ensuring current flows in only one direction. Generators are everywhere in our modern world. Power plants use massive generators to produce electricity for entire communities. Car alternators are small AC generators that charge the battery while the engine runs. Hydroelectric dams use falling water to spin turbines connected to generators. Wind turbines capture wind energy and convert it to electricity through generators. All of these applications rely on the same fundamental principle of electromagnetic induction.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.